All right, for part 4, because we're still dealing with triangles, you gotta remember all triangles equal 180. So we want to use adding up 3 angles to equal 180, or you can use your exterior angle theorem. So if I have an angle outside, I can add it to its remote interior. So you want to start with the triangle that you have measures to. You want to use either vertical angles or linear pair. So like if I start with my angle 125, it is a linear pair to angle 3 or to angle 2. So I'm just taking 180 minus the 125. So we should see that we have here is 55, and this would be 55. If I want to start with vertical angles, that would be the 65 over here. It is vertical to the 8. So that's 65. Now, to get to either a triangle with angle 1 or the triangle angle 4, with angle 1, let me just make some room right here. If I look at this triangle, oops, sorry. Maybe this triangle here. To get to that angle 1, I'm going to use this exterior angle. This exterior angle corresponds with these two. The sum of 50 and 1 equals 125. So angle 1, hold on, let me first write it. Angle 1 plus the 50 degrees equals 125. So I can just subtract, work backwards to get to my angle 1. Or I want to use triangles that I have 2 angle measures with. So I could do that with this triangle here. I have the angle 3, which is 55, and then the 85. So now I can get this missing angle 4. And if I can find that missing angle 4 here, it's going to be the same as angle 6. And now I can move on. Okay. So I do want you to try to do these. And kind of gave you some of the answers already. So just go back and listen to the video because I just kind of said what to do to get to this. Like I know these two together are 140. So that's going to be easy to get to angle 4, which is equal to angle 6. And now I have another triangle here. Now I can use this triangle to find my missing angle 7. Okay, you want to use triangles to get to that part. All right, now when you get to these 51 and 52, you're using special types of triangles. So we should start with this triangle that I have angle measure it with, and that's isosceles. So that lets me know that if I have the vertex angle 56, then these base angles here are going to be the same. So all I have to do is say 180 minus the 56. Oops, I wrote 52, sorry. 180 minus the 56 divided by 2. And that gives me each angle. I need that to get to this adjacent angle. This comes out to be 62. And now that I know that 62 and this angle here is adjacent to it, I could do 180 minus 62, which is 118. And now I'm using the next triangle. And this triangle is also isosceles. It has these tick marks as well. So now I can know that if I have two sides that are congruent, these two base angles are also going to be congruent. So see if you can get to that. To get to XYZ, you need to find your X first using this triangle because they gave us the 30 and the 50. So that's going to give me 110. So this missing angle here, X is going to be 70. If I know this is 70, I now can move to angle Y because they are on this line. And that would give me 110, and now I can get to my angle Z. Okay, you got to start with one triangle, move to the next. All right, now we need to know all the types of triangles. If it's equilateral, this means we have 3 congruent sides. We just want to name an example of that with this diagram. If it's isosceles, we have 2 congruent sides. And if it's scaling, no congruent sides. No sides that are equal. Acute, we should know acute angle, right angle, obtuse. So if I want to name an equilateral triangle, I'm looking for 3 tick marks. So there's my 3 tick marks right there. So triangle A, I can say ADC. If I'm trying to do an isosceles triangle, I just want 2 tick marks. Well, that's right here. So that's triangle ACB. No common tick marks. Well, that's the whole triangle. I put the 2 together. That's 1 tick mark, no tick mark here, and then 2 tick marks there. So this would be triangle ADAC. An acute triangle needs acute angles. So if it's equilateral, don't forget that each angle is equal to 60. So this could also be my DAC acute triangle. And if it's right triangle, it has the right angle. So we need the box to show that it's a right angle, 90 degrees. So that would be our triangle DAB. An obtuse triangle, we need one obtuse angle, and there is an obtuse angle right here. I know that because if this is 90 and that's 60, this is 30. This is 30. That would be 120. And vice versa, linear pair. So that's triangle ACB. Okay, so you're just naming from the diagram. If it's a triangle, to know it's a triangle, you take the sum of the 2 smallest numbers, the sum of 2 smallest sides. Oops, sorry, I can't write today, sorry. Sum 2 smallest sides has to be greater than the 3rd remaining side. So the 2 smallest sides here are 24 and 5. 24 and 5 is 29. Is 29 greater than 26? Yes. So this is a yes. 2 smallest sides here are 4 and 7. 4 and 7 are 11. 11 is not greater than 11. So this is no. So that takes care. Oh, I'm sorry. My last part, 61. The range, when dealing with range of the 3rd side, we have to do the min is less than x, which is less than the max. To get the min, we subtract the 2 numbers. Min is subtraction. Max is you're adding the 2 numbers. So if I subtract these 2 numbers here, the 7 and the 4, then our min would be 3. Our max would be 11. So our 3rd side has to be between 3 and 11. Okay, that's the range right there. All right, so that takes care of 4, and now we're on, I believe, our last section, which is our unit 3, or 3B. It's the last half of the unit, where you have to know your parallel and perpendicular lines, slopes, and equations. All right,